Hi, and welcome to Section 5.2, Verifying Trig Identities. The key to verifying identities and solving equations, is where we're going to move a little bit, is your ability to use the fundamental identities, which we talked about last time, and then you need to remember all of your rules of algebra to rewrite trig expressions. So here you have some guidelines for verifying trig identities. I would go ahead and jot some form of this down in your notes. You don't need to copy it word for word, but you're going to want to start with one side of the equation at a time. You're going to want to try to factor, add fractions, square a binomial, create a monomial denominator. You're going to want to look for opportunities to use those fundamental identities, which we talked about last time. And you're going to want to sometimes convert everything to sines and cosines. That's a favorite strategy of mine. And number 5 is crucial. You always try something. Make some kind of attempt. It may lead you to a dead end, but this will give you some insight on where you really should be going. And I do this all the time. I try something and it doesn't work, so I have to go back and start over and try something different. So your possible strategies are that we just talked about: combining fractions, converting everything to sines and cosines, and working each side separately. There's page numbers in the book if you want to read a little bit more about that. Let's jump right in and try to work on establishing this identity. One more thing that you need to know, or you need to consider when you're verifying identity: right now you cannot assume that those two sides are equal. So you can't add 1 to both sides or divide both sides by tangent, or whatever you're thinking about those normal kind of algebraic things. You're going to start with one side of the equation and work with that. You're not going to be working with both sides. When I look at this guy, example 1, I don't see, I have to get this side to look like secant. As it's written, I really don't know what to do. So I'm going to fall back on one of my favorite strategies and write everything in terms of sine and cosine. So the first thing that I do is I write out my original left-hand side. That is the most complicated side, so that's what I'm going to work with. And I'm going to say that that is equal to, and I'm going to do some substitutions here. Cosecant is 1 over sine, and tangent can be rewritten as sine theta over cosine theta. This is looking promising to me because now I have sine theta over sine theta cosine theta, and I can cancel my sine thetas and I am left with 1 over cosine. We try to never leave the trig function in the denominator here, so I would rewrite that as secant, always paying attention to that's where I was trying to get to right from the start. So the next one that I want to look at, we want to establish that this identity is true. We want to establish this identity. I could, rewrite these in terms of sine and cosine. However, when I look at the cosecant here and I see the cotangent, I remember my Pythagorean identity that uses cotangent and cosecant. I'm going to write that down over here. It is 1 plus cotangent squared is equal to cosecant squared. Sorry. Okay. So I need to see if I can somehow get this, and I see, well, I'm going to end up with a squared if I FOIL these, multiply them together. So I'm going to go ahead and multiply these two binomials. Start out with my original left-hand side because it is the most complicated side. And I am going to say that that is equal to cosecant squared. Whoops, sorry. Got a little ahead of myself there. So cosecant squared theta. When I multiply my outers and my inners, notice that those cancel. So I just end up with cosecant squared theta minus 1. Well, that is very close to what I have over here, except over here cosecant squared is by itself. I have already established that this is an identity, so I can subtract 1 from both sides, and I get that cotangent squared theta is equal to cosecant squared theta minus 1. Notice that this is exactly what I have over here, so I can say that this is equal to cotangent squared theta, which is exactly where I needed to go. I meant to say this in the slide up here, but notice that this is not your answer here. This whole process is your answer. So it's not just the thing that you're trying to get to, it's the whole process. Make sure that you write everything out. It is going to take a lot of writing. It is going to take several steps, but you just can't say that this is equal to this. You need to show your process of how you got there. Let's look at one more. And this guy's a little tricky, but if you go back to your guidelines and it says that, I want to add fractions, create a monomial denominator. Well, I'm not going to be able to get a monomial, but I need to add the fraction, so I have to have a common denominator. I have 2 terms over here, and I have 1 term over here, so I somehow have to be able to add these together. So I am going to rewrite 1 as a fraction. And first of all, let me get my original left-hand side. It is the most complicated side, so that's where I'm going to start. And now I'm going to rewrite 1 as a common denominator of 1 minus cosine theta. Notice that 1 minus cosine theta divided by 1 minus cosine theta is 1. And then from that, I will subtract sine squared theta over 1 minus cosine theta. Now I can rewrite that as one fraction. I have 1 minus cosine theta minus sine squared theta all over 1 minus cosine theta. Well, I see a lot of cosines here, and I do know that I can rewrite sine squared as cosine squared somehow with my Pythagorean identity. Let's take a look at that over here. We have sine squared theta plus cosine squared theta has to equal 1. This is an identity, so I can manipulate it. I need to get sine squared by itself here, so I'm going to subtract cosine squared from both sides. And now I see where I can get a substitution that I can use in the proof that I'm working on, the establishing that identity. 1 minus cosine squared theta. So I can take right here and I can substitute that because they mean the same thing. So doing that substitution, I have 1 minus cosine theta. Okay, so now I have minus 1 minus cosine squared theta. And this is all over 1 minus cosine theta. I have a couple more steps to go, I think. I'm ultimately trying to get to negative cosine. So it's looking promising. Something's going to cancel here. Let's go ahead and rewrite the top. It is 1 minus cosine theta. Okay, when I distribute this negative sign, I get minus 1 plus cosine squared theta all over 1 minus cosine theta. My 1's will cancel, and I can rewrite this as, notice down here I have a 1 minus a cosine theta, so I can go ahead and rewrite this top as negative cosine theta plus cosine squared theta, and it is all over 1 minus cosine theta. Now I need to, if I factor out a I see I can factor out a cosine. If I factor out a negative cosine, I will end up with a positive 1 and a negative cosine here, which is exactly what I need. So I'm going to factor out a negative cosine theta. So I divide this by that, and I get 1. I divide cosine squared theta by negative cosine theta, and I end up with minus cosine theta. And this is all over 1 minus cosine theta. And this is lovely because these will cancel. And I end up with negative cosine theta. And all along, that's what I was, I was aware all along that I needed to get this left-hand side equal to negative cosine theta. I have reached my goal. I am finished. Once again, guys, the process is the answer. It's not just that last step. So this entire process is how you establish that identity. This is it for this lesson. Please make sure that you come to class with questions, and we will be working on doing these by ourselves. Thank you.